Hey students, today we are going to study how to find centroid of a composite plane shape. A composite shape is combination of standard shapes. For example, here is a semicircle. Do you know how to find area of a semicircle? Yes, it is pi r squared by 2. What if I attach a rectangle to this semicircle in this manner? This is a composite shape. It is combination of standard shapes, a semicircular area and a rectangular area. Will you be able to find total area? Simple. It is school level problem. Area of semicircle plus area of the rectangle. Now what if I make a hole in this area? This is how. So now the remaining area will you be able to find? Yes, area of semicircle plus area of rectangle and subtract area of the circle. So finding area of a composite shape, that is not a problem at all. It's school level problem. Similarly, to find centroid of a composite shape is simple problem. Provided you know position of centers of standard shapes. Before I tell you position of centers of some standard shapes, we'll discuss something else. For example, I've seen many students getting confused about centroid, center of gravity, center of mass. First of all, let's have proper understanding of this concept. Here is a rectangle of base B and height h. So geometrical center of this shape is its centroid. So if you join midpoints of opposite edges, then this is how you will be able to locate the center of this rectangle, and that is its centroid. Here it is a rectangular plate, rectangular steel plate. It is a body, so it has a shape and therefore it has a center of its shape. And it is a body made of steel, it has certain mass and therefore it has a center of mass. Center of mass is a point where mass of the body is assumed to be concentrated. So here it is a plate of base B and height h. Just focus on its shape and you will be able to look its center of its shape. So that is centroid. In case of a homogeneous body, centroid and center of mass coincide. So centroid and center of mass G, they coincide in case of homogeneous bodies. Now here it is again a rectangular plate, but upper portion of the plate is made of wood and lower portion of the plate is made of steel. Now we can easily locate centroid of its shape. You know that density of steel is more than density of wood. Since lower portion has more mass as compared to the upper half, center of mass shifts closer to the lower edge. There is nothing like center of mass of a rectangle. It is absurd term because a rectangle is a geometrical shape. It doesn't have mass and there is nothing like mass center of a rectangle. But what if it is a rectangular plate? Yes, this is a body and therefore it has certain mass and it has mass center. And also it has certain shape and therefore it has centroid. So from all these discussion, what you should understand, centroid is center of a shape. Center of mass is the point where mass of a body is assumed to be concentrated. And center of gravity is the point where gravitational force acting on the body is assumed to be acting. These three terms are different concepts, so remember carefully. Now, in case of homogeneous bodies, centroid and center of gravity coincide. In case of non-homogeneous bodies, centroid and center of gravity may not coincide. And the bodies which we observe in our day-to-day life, in all those bodies, we assume that center of mass and center of gravity coincide. Now let's talk about centroid of standard shapes. So a rectangle is a standard shape. So here is a rectangle of base B and height D. B by 2, that is horizontal distance from vertical edge, and d by 2 vertical distance from horizontal edge. Here is a right angle triangle of base B and height d. Somewhere here center of that right angle triangle should be. But it's not somewhere, you know now exactly where it is. From the base it is d by 3, 1/3 of its height. And from the vertical edge it is 1/3 of its base. Isosceles triangle is a standard shape. So here is an isosceles triangle of base B and height d. Isosceles triangle is a symmetrical triangle. So I have drawn axis of symmetry which joins apex and center of base. Centroid of an isosceles triangle lies on its axis of symmetry. But exactly where? Centroid of an isosceles triangle lies on its axis of symmetry at distance 1/3 of its height from base. Now here one more example of isosceles triangle. Centroid of an isosceles triangle lies on its axis of symmetry at distance 1/3 of its height from base. The height of an isosceles triangle is measured along its axis of symmetry. So 1/3 of height from its base. Now circle is a standard shape, and as you know that centroid is geometrical center of a shape. The center C of the circle is nothing but its centroid. Simple. Now quarter-circular area. R is a radius of this quarter-circular area. A radius at the boundary, and here is also a radius at the boundary. Centroid of this shape is somewhere here, but it's not just somewhere here. You know exactly where it is, and it is at distance 4r by 3 pi from its perpendicular edges. So from this horizontal edge, vertical distance of centroid is 4r by 3 pi, and from this vertical edge, horizontal distance is 4r by 3 pi. Here it is a semicircular area. It is a symmetrical shape. I have drawn axis of symmetry. A radius of this semicircle is r. It is semicircular area. Centroid lies on its axis of symmetry. And where it is? On the axis of symmetry at a distance 4r by 3 pi from its straight edge. How to find area of a semicircular area? Pi r squared, which is area of whole circle divided by 2. Now here is a semicircular area. Here it is axis of symmetry. R is the radius of the semicircular area. What do we know? Centroid of a semicircular area lies on its axis of symmetry. On the axis of symmetry at a distance 4r by 3 pi from its straight edge. Let's proceed. Here is a circle of radius r, and now check. Portion of a circle bounded by two radii. Here it is a radius at boundary of the shape. Here it is radius at boundary of its shape. So this shaded or blue colored area is a sector. Alpha is a semi-angle of sector. The line bisecting the angle of sector. What is angle of sector? 2 alpha. Alpha is a semi-angle of sector, and angle of sector is 2 alpha. The line bisecting angle of sector, that is this vertical line, is axis of symmetry. Can you tell me formula for area of a sector? Alpha r squared. R is radius of the sector and alpha is semi-angle of sector. This is about area. Now where is centroid of this sector? So centroid of a sector lies on its axis of symmetry. At a distance 2r sine alpha by 3 alpha. What is r? A radius of the sector. And alpha is semi-angle of sector. And now one more thing I would like to tell you here. Since we use calculators to calculate these values, you will have to take care of mode of your calculator. Default mode of our scientific calculator is degrees, and therefore to find trigonometric values you should use value of alpha in degrees. So at a numerator this alpha you must use in degrees, and at denominator this alpha is in radians. For example, if this alpha is 30 degrees, then in numerator you should write sine 30 degrees, and at denominator instead of 30 degrees you should write the value 30 degrees in radians. And how much it is in radians? Pi by 6. So remember, at a numerator alpha in degrees, at denominator alpha in radians. Now here one more circle. And what is this shape? Again a sector. Centroid lies on its axis of symmetry at distance 2r sine alpha by 3 alpha. Remember this form. At a numerator alpha in degrees, at denominator alpha in radians. R is radius of the sector and alpha is semi-angle of sector. Remember, R is radius of the sector and alpha is semi-angle of the sector. Now you know location of centroid of standard shapes. So you are ready to solve problems on composite shapes. But before we start solving problems on centroid of composite shapes, those students who don't know me, I am Professor Rajendra Bade and I have more than 30 years of experience teaching this subject to Mumbai University students. And one more thing, if you think that you are getting benefited by this video, share this video with your friends. Like the video, subscribe my channel, leave some comments below. This interaction is going to encourage me to upload many more such videos. So let's begin solving problems on composite shapes. So here it is example 1. Find centroid of the shaded area. To find centroid means what you are going to do? Simple. How we define position of a point in a plane? By coordinates. We choose a horizontal reference axis, a vertical reference axis, x-axis and y-axis, and we define position of the point in that xy plane. So to find centroid of the shaded area means to find coordinates of centroid of the shaded area. Okay. So how to do that? Let's try to do that. It's a very simple problem. If you know position of center of standard shapes, you will be able to locate position of center of a composite shape. First of all, watch the given shape very carefully. Check if there is a hole or a slot involved, that is, remove the area involved. And if you think that there is certain area removed, first of all, fill that area in your imagination. So this semicircular area, watch here, I have filled in my imagination. So fill that area, and then what area you get it? You divide it in standard shape. So I have divided this area into standard shape, a rectangle and a triangle. And now we should remove the semicircle so that we'll get the given area. So I have removed the semicircle. So watch the diagram very carefully and identify the areas involved. Which standard shapes are to be added and which are the standard shapes to be removed to arrive at the shaded area. And we have identified very easily. There is a rectangle, there is a triangle, rectangle and triangle to be added and semicircle to be removed. And now we'll draw a diagram to analyze the problem. Y-axis and x-axis. Origin is given. So horizontal line through origin is x-axis. Vertical line through origin is y-axis. Now we have identified standard shapes involved here. So draw these shapes one by one in this diagram. So there is a rectangle. When you draw the shape, immediately insert the corresponding dimensions and label that area as A1. A1. That is first standard shape involved in this diagram. Second area is triangle. What dimensions are required for a right angle triangle? Base and height. So base is 60 and height is 90. Here it's mentioned dimensions are in millimeters. So base is 60 millimeter, height is 90 millimeter for this right angle triangle. Label it as area A2. Now A1 plus A2, is it the given area? No. So from this combination of A1 and A2, we should remove the third area, and that is semicircular area. So here it is area A3, which is removed area. So this is how divide area into standard shapes. Now locate centroid of each standard shape. So centroid of rectangle, and you will not face difficulty here because you know position of center of standard shape. What do you know about centroid of a rectangular shape? H by 2, B by 2 from its edges. So somewhere here it is a centroid of rectangle, but not somewhere here. You know where exactly it is. So vertical distance is half of its height and horizontal distance is half of its base. Somewhere here, centroid of second area, label it as C2. C2 is centroid of A2. It's not somewhere here, we know exactly where C2 is. Distance of centroid of a right angle triangle from its perpendicular edges, we know H by 3, B by 3. So this vertical distance is 1/3 of height, this horizontal distance is 1/3 of base. Height is 90, so 1/3 of height is 30. And base is 60, so 1/3 of 60 is 20. And what do you know about centroid of a semicircular area? It lies on its axis of symmetry. So I have marked it on axis of symmetry C3. And where exactly on the axis of symmetry? At distance 4r by 3 pi. But I have labeled right now that distance as A. A is 4r by 3 pi. That is 4 into 30. Radius of this semicircle is 30. 4 into 30 divided by 3 pi. And it is 12.73 millimeters. So we know centroid of each standard shape. So here is the final diagram in which we have shown all the three areas involved. We have shown location of center of all the three areas from corresponding boundary. Remember that. So 30 and 45, H by 2, B by 2, that is distance of centroid of this rectangle from its base and vertical edge. C2, H by 3, B by 3 from edges of this right angle triangle. And A, that is nothing but 4r by 3 pi, it is distance of C3 from its straight edge. Make a table in this manner. In first column, we are going to show these three shapes. In second column, we are going to write corresponding areas. Third column and fourth columns are XY coordinates of corresponding center. So here first area involved is a rectangle. So in the first column, draw similar but smaller shape of A1, that is this rectangle. Similar, smaller in the same orientation. How rectangle is placed in this diagram, check it, and in that orientation you draw the diagram. And this area is base 60 into height 90, base into height, so you will not face this difficulty. Now second area is right angle triangle. Draw a right angle triangle, a small figure. Similar right angle triangle and in the same orientation. And area A2, 60 base, height 90, so 60 into 90 divided by 2, base into height by 2. So this is area of triangle. No problem at all. And third area is semicircular area. Draw semicircle in this orientation. And what is area of circle? Pi r squared, but it's semicircle, so pi r squared by 2, that is pi into 30 squared by 2, so it comes out to be 450 pi. But most important thing is, it is negative area because it is a removed semicircle. So total area is A1 plus A2 plus A3, that's why I've mentioned here AI, summation AI. Remember, in this addition, semicircular area must get removed, and that is why we should use negative sign with the removed area. Now add these three areas considering the negative sign, and this is the total area, 6686 millimeters square. And now XY coordinates. Remember, horizontal distance from Y axis, that is X coordinate. So horizontal distance of C1 from y-axis, that is 30. X coordinate is horizontal distance from y-axis, so be careful. What is x coordinate of C2? So it's horizontal distance of C2 from y-axis. So focus on all horizontal dimensions. So it is 60 plus 20. It is 60 plus 20, that is 80 millimeters. And remember, these are not just distances, these are coordinates. So on the right side of y-axis, x coordinates are positive, you know it. And that's why both these coordinates 30 for C1 and x coordinate of C2 also positive. In fact, all the three centers are in first quadrant, means all coordinates are positive here. So x coordinate of C3, that is horizontal distance of C3 from y-axis, and that is 30. So these are all x coordinates. Now let's write y coordinates. Vertical distance of C1 from x-axis. When you write y coordinate, be sure where the x-axis is, and then you start writing coordinate. So vertical distance of C1 from x-axis, that is y coordinate, and that is 45. Vertical distance of C2 from x-axis, that is y coordinate of C2, and that is 30. All centers are above x-axis, so all y coordinates are positive. So vertical distance of C3 from x-axis is A in the sense 12.73 millimeters. So this is how all necessary values or corresponding values in this table we have inserted. So area and xy coordinates of corresponding centers are there. So this is area A1, numerical value of area A1. Here it is x coordinate and here it is y coordinate of center C1. So A1, this is x1 means x coordinate of C1, and here it is y1 means y coordinate of C1. Here it is x coordinate of C2, here it is y coordinate of C2. And this is area A2 in millimeters square. We are interested in finding centroid of the entire given shape. So this is how we find it. X bar is x coordinate of centroid of the composite shape, and y bar is y coordinate of centroid of the composite shape. So to find centroid means to find coordinates of the centroid, to find x bar and y bar. And now you know mathematical meaning of this expression, summation ai xi means a1 x1 plus a2 x2 plus a3 x3 and so on. Summation ai means a1 plus a2 plus a3, but value summation ai is already known here, 6686. Okay, so let's put the values in the formula. So x bar is equal to, now let's write numerator. So a1 into x1, this is a1 and here it is x1, plus a2 into x2, here it is a2 and here it is x2, 2700 into 80, and plus a3 into x3, but a3 is negative 450 pi, so minus 450 pi into 30 divided by total area, and that is 6686. Now complete the calculations and you will get x bar 50.19 millimeter. Similarly, y bar is summation ai y divided by summation a. So a1 into y1 plus a2 into y2, a1 into y1 5400 into 45, a2 into y2 2700 into 30, and a3 into y3, so minus 450 pi into 12.7 divided by total area. So this is how you will get y bar. So final answer is x bar, y bar. Find centroid of given area means find coordinates of the centroid.
Very simple. If you know position of centroid of standard shapes, you will able to find centroid of a composite shape. These are not time consuming problems at all. I took so much time because I wanted to explain you in detail. But one more thing I'll tell you. Drawing neat diagram, inserting all dimensions, that is the key. If diagram is perfect, you have inserted all necessary dimensions carefully, then you will not face any difficulty in solving these types of problems. Let's solve one more problem.
So here is an area. Find centroid of the shaded area in figure. If you think that something is removed here, to fill it first. So quarter circular area, let's fill that. So fill it in your imagination. Actually this is the given area, but in our imagination we have filled it. So holes, that is removed areas, slots, removed areas. First of all you fill those areas and then identify the standard shapes involved. So there is a semicircle involved, there is a rectangle involved, there is a triangle involved. So if you add these three areas, you will get this area. This is a total area, but not given. From this area now, we should remove the quarter circular area. Since origin is given, now horizontal line through origin is x-axis and vertical line through origin is y-axis. So let's draw diagram of the given shape. Shape by shape. We have identified 4 standard shapes here. So one by one we'll draw those standard shapes here and complete the given diagram this way. A rectangle, base 60 and height 90. Right angle triangle as second area. So what is height of the right angle triangle? You will able to tell me. Check here. Diameter of the semicircle is 150 minus 90. So 150 minus 90. So height of the right angle triangle is 60. So these are the dimensions for the right angle triangle. Immediately insert dimensions of corresponding area. Now third area is semicircle. Whenever you draw semicircle, draw its axis of symmetry. That's important. And insert radius. It's better way to insert the radius along straight edge of the semicircle. So I am inserting this way, parallel to the straight edge, 75 and 75. By inserting a radius along corresponding straight edges, radius of semicircle, radius of quarter circle and radius of sectors, if you insert along straight edges, then it helps you to identify coordinates of different centers. And finally, removed area, quarter circular area. Insert radius of the quarter circle along its straight edges. So this is radius 60 of the quarter circle. Here I have shown radius 60 of the quarter circle. So this is how we have shown all the 4 areas with corresponding dimensions. Dimensioning is very important. Now let's look at center of each standard shape. So area A1 is rectangle. So somewhere here its center C1 is. H by 2, B by 2, we know that. So half of 60 and half of 90. All dimensions are in millimeter here. So half of 60, 30 and half of 90, that is 45. So from vertical edge of the rectangle, distance is 30. From horizontal edge of the rectangle, distance is 45. Now second area is a right angle triangle. Focus on this right angle triangle. Somewhere here it is C2. First of all mark that point and then insert distances in this manner. Horizontal distance is 1/3 of corresponding edge and vertical distance is 1/3 of vertical edge of this right angle triangle. So height is 60, so 1/3 of height, that is 20. And horizontal edge is 150, so 1/3 of 150, that is 50. Now what do you know about centroid of semicircular area? So it lies on its axis of symmetry. So I marked that. On axis of symmetry at distance 4r by 3 pi. So right now I have labeled that distance as A and I'll show calculations here for A. Fourth area is quarter circle. So focus on that quarter circular area and somewhere here that center of quarter circle is C4. What do you know about centroid of a quarter circular area? From its straight edges 4r by 3 pi. So this distance is 4r by 3 pi. This vertical distance is also 4r by 3 pi. We'll have to calculate it. But right now in the diagram I have labeled it as B. Centroid of quarter circular area lies at a distance 4r by 3 pi from perpendicular edges. Okay. Now let's calculate first value A. Use corresponding radius which is 75 and this is A. Similarly, B is equal to, use corresponding radius 60. For expression is the same 4r by 3 pi and you will get B as 25.46 millimeter. So diagram is complete now. That is, we have shown all 4 areas involved and we have located centers of all 4 areas with corresponding distances from corresponding boundaries. Okay. Now make a table. Shape. area in millimeter square, x coordinate in millimeter and y coordinate in millimeter. First shape is rectangle A1. It is 5400, 60 into 90. Second area is right angle triangle, 60 into 150 divided by 2, that is 4500. Third area is semicircular area, pi r squared divided by 2, pi into 75 squared divided by 2. And fourth area is quarter circle, so area of circle divided by 4. So quarter circle, radius is 60, so pi into 60 squared divided by 4. This is area of quarter circle. Removed quarter circle. This is area of removed quarter circle. Do not forget that negative sign because it is removed area. And this is how you will get the total area. Now let's write xy coordinates of centers. X coordinate of C1. Don't blindly write it as 30. Here it is x-axis, here it is y-axis. Since origin is given in the diagram, we could locate xy axis. So horizontal line through origin is x-axis, vertical line through origin is y-axis. So horizontal distance from y-axis is x coordinate. So watch carefully here. All centers are on the left side of y-axis. What does that mean? All x coordinates are negative. On the left hand side of y-axis, x coordinate negative. So be sure about y-axis before you start writing x coordinates. So horizontal distance of C1 from y-axis, that is 30. So put here with negative sign because it is on the left side. On the left hand side of y-axis, x coordinates negative. Now horizontal distance of C2 from y-axis. Now watch carefully. This is that horizontal distance of C2 from y-axis. And how much is this distance? Wait here. Base of rectangle is 60 and 60 minus 50, that is 10. This distance is 10 millimeters but on the left hand side of y-axis. So minus 10. So x coordinate of C2 is minus 10. Then x coordinate of C3. Horizontal distance of C3 from y-axis. Check. Horizontal distance of C3 from y-axis. So focus on all horizontal dimensions from y-axis up to C3. And then it is 60 plus A. And how much is that A? 31. So it is 91.83 on the left hand side of y-axis. So negative. And now x coordinate of C4, it is on the left side of y-axis. And this is that horizontal distance. And how much it is? B. B is 25.46. So these are all x coordinates. Now let's write y coordinates of all centers. Vertical distance from x axis, y coordinate. So check first of all where is the x axis. Be careful about that and write all y coordinates. So vertical distance of C1 from x axis, that is y coordinate. How much is that? 45. And it is above x axis. So positive y coordinate. Above x-axis, y-coordinates positive. Below x-axis, y-coordinates negative. So C2 has negative y-coordinate. So vertical distance from x-axis. So check again. Vertical distance from x-axis, that is y-coordinate. So it is minus 20. Vertical distance of C3 from x-axis. Now C3 is above x-axis, so y-coordinate positive. But which is that distance? It is 15. 15, of course. Height of the rectangle. This height is 90 millimeters. So 90 minus 75. That is 15. Or 75 plus 15, that is this 90. So be sure that you are writing correct coordinate for C3. Basic logic is vertical distance of C3 from x-axis. That is y-coordinate. And it is above x-axis, so positive y-coordinate. 50. Vertical distance of C4 from x-axis, that is y-coordinate. This is that distance. And how much is it? It is 90 minus b. So 90 minus b, it is 64.54. this center C4 is above x-axis, so corresponding coordinate is positive. X bar is equal to summation ai xi divided by summation ai. So ai xi means a1 x1 plus a2 x2 plus a3 x3 plus a4 x4, but take care of negative signs and you will get x bar, and y bar is summation ai yi divided by summation. You will be able to do this calculation. Just put these values in this formula and get the answers.
Thank you so much for watching the video. If you have liked the video, share it with your friends. They will also get benefited. And don't forget to subscribe my channel. And if you want me to solve some more problems on Centroid, leave a comment below. Thank you.